Hi everyone, welcome back to Automate Live. My name again is Jana Martin at the Association for Advancing Automation, and I'm really excited to be back here on the desk now with Zachary Gray. He's the Business Development Manager for Additive Manufacturing at Siemens. Zach, thanks for being here today.
Thanks for having me.
All right, so additive manufacturing, 3D printing, that's your expertise. Let's dive into it. But first, just tell me a little bit more about what is your role and what do you do at Siemens?
So my role at Siemens is kind of very broad. I do many different projects, from financing topics to digital factory planning to supporting different machine builders, but also machine users on how they can use Siemens technology and industrialized additive manufacturing. So going from an R&D environment to a full industrial factory-based machine.
Okay, and so the overarching theme at Siemens is industrialized additive manufacturing. What exactly do you mean by that?
So when people normally think of industrial 3D printing or just 3D printing in general, they think of a tabletop machine.
Exactly.
Some type of a fused deposition modeling machine, a small 3-axis gantry that might sit on your table for prototyping.
Right.
Yes. But we're starting to use a lot of these different additive modalities in general industry. So end-use parts, repair parts, still prototyping, that's also there. But from a Siemens perspective, whether it be our hardware or software, we truly believe, and we've proven it out in traditional manufacturing techniques, how you can utilize platforms of our industrial controllers, of our industrial software and platforms that produce a more ruggedized, repeatable process and part and really concept of how you would do those additive manufacturing techniques.
That's so awesome. Now, what would you say is really the biggest challenge with this? Just because, industrial grade additive machine builder, like it's different materials. There's a kind of a different standard there.
Yeah. One of the biggest challenges is definitely understanding where the different type of machine fits. So a lot of people think of a additive manufacturing machine, a 3D printer, as something from like Star Trek, a replicator. It will never do everything for every application.
Right.
You have to understand what build volume it is, what type of material it is, does it make sense cost-wise, are you producing a part that is going to be different than how you've been producing it for 40 years? How does that fit in? So a lot of people coming from general industry, automotive, aerospace, large-scale industrial machinery, they're like, well, we know what additive is. Like, yeah, we want to use it, but they don't even know where to start.
Right.
So helping them get to the point where they can even talk to the machine builder or the consultant or whoever it might be, that's probably the biggest challenge.
I can see that. And I mean, just helping people realize, like, you don't have to rebuild the whole entire part. You can use this technology just to fix that part of it that's broken even, which is incredible. Okay, so what additive manufacturing techniques excite you most as an engineer? That's your background. I mean, let's geek out on this. What is so fun about 3D printing?
So it's the sky's the limit type of a thing.
Yeah.
So I guess if I had to pick a modality that I've been most connected to, it's probably directed energy deposition, just from my history.
Okay.
However, we're doing a lot of great things with vat polymerization and binder jetting that really interests me, because it's something a little bit newer for me that I'm kind of dipping my toe into, if that makes sense. I mean, you'll never know everything, right?
No.
Never can know everything.
No.
And from my history, and I come from robotics and machine tool background, there's a lot of synergistic type approaches to those technologies that's similar to how a traditional subtraction mill or robot has been applied there, which makes me, be able to apply that base level knowledge from before to it.
Yeah, can you explain that a little bit more? Like, what are the differences there with the subtractive manufacturing?
For sure, and there's a lot of crossovers too. So
okay,
you'll sometimes machines aren't just doing 3D printing. Sometimes they're a hybrid application where you print something, you scan something, then you might be taking away some material with a mill, all in the same machine, or kind of separate from that. Now, if you think about a tool center point or how you're depositing that material, there's a lot of ways that you're going to program that and tie in the actual end effector of whatever it is, so a gantry or a robot, something like that, but tie that into the motion profile. So very similar from thinking of it not just as a spindle at the end of it, right? But extruding out some type of a polymer or pushing metal out with a wire and somehow melting it or bringing it to a point where you're manipulating it into a shape.
Very, very cool. Okay, so are the end users of 3D printing, additive manufacturing today mostly emerging new companies or subtractive product manufacturers who have jumped into this new technology, or both? What are you seeing?
It's very broad. Like, you know, I could probably give you examples of very new ones all the way to a traditional manufacturer that's starting to dip their toe in it.
Right.
If you think of composites manufacturing, which let's say it's the most traditional 3D printing or historical, right?
Yes.
A lot of them are traditional manufacturers that see benefits of using this new technology.
Right.
Especially,
you don't have to sell them. They know what it is.
Yes.
They want it.
Yes. And they might have been testing it out for the last 10 years, right? They had it in an R&D facility that they had. They're a large prime or tier one in one of those main industries. They know what they want. They've been trying it. But on top of that, there's a lot of people that come and just have no idea. They've heard additive manufacturing. They might even be a small job shop, right? And they're like, how can I utilize that? How can I have something unique in my world? I've even from a Siemens perspective, I've been using Siemens technology for traditional manufacturing. How can I take some of that knowledge and apply it to the additive space?
And what do you see being that transition point for those who have been thinking about it, and what finally gets them over that edge? And when you talk to that smaller company, what makes them realize, okay, we've got to invest and dive into this because it's going to...
Blank, yeah. I guess the biggest thing about it is they don't want to be left in the dust, right?
Right.
Whoever their competitor might be, they are doing something different that they cannot do.
Right.
They see a benefit for a part that they can manufacture that they weren't able to manufacture before.
Whether that be the design of it, mostly.
How it's actually modeled, material.
Right.
All those different things.
All
and
these details.
that's the cool thing about Siemens. We go all the way from the beginning with software of design through simulation down to actually putting that part program to the machine, and then how you're driving that machine. How are you getting the analytics off of it?
Wow.
Siemens is end to end.
Yeah.
We always like to say that, but for that, it's so tight into additive, because if you're not designing it for additive, what's unique about it, well, then just do it how you've always done it, right?
Exactly.
Leverage the benefits.
Actually take advantage, exactly. Okay, here's a fun one. Let's compare your subtractive manufacturing days with today's and tomorrow's additive landscape in machine building. There's a joke going around that says you only need to write the algorithm backwards. Explain that for those that don't understand.
I wish it was that easy, right? that all you had to do is take your part program for what you were doing on a mill that's taken away some material from a block, and you could just write it backwards, and then now it can produce the same part. But it's so much more in depth, understanding the design characteristics of that part, and how are you going to build it on those each individual types of industrial 3D printers.
Right.
And it's more than even just thinking about a slicer. So everybody talks about that's a traditional, or not traditional, but it's a used word in the industry.
Absolutely.
About how you're deconstructing the part and layering it, build layer by layer. But it's more than that. You have to actually understand how the energy going into it, maybe the laser, if it's a certain system, how's that going to interact with the part next to it? So.
Oh, wow.
Yeah. So there's a lot of pieces. It's not just hit a button, right? A lot of smarts, AI pieces that can be built in the individual components of a machine. How do you use that to automate the process from all the way from the design to actually printing it and making sure it's the first time right?
I mean, that's something we talk about all week here at the desk, is how is artificial intelligence making all of these processes better in automation. Can you talk a little bit more about the way AI and additive manufacturing, like where do you see that going in the future, and what excites you about that?
Well, because it's so, we like to talk about digitally native. You have to use it on some type of a computer program. You're designing that part and designing how the machine's going to print. Well, if you start to build in automation and true AI capabilities, that can cut down that process, and it can learn from it a lot better than what just one operator, one designer can do. So we're, even at Siemens, got to do that plug or whatever, we have AI capabilities in a lot of our different platforms, particularly our factory automation platforms.
Right.
And we've been applying that with different key machine builders on how to do it for their process.
That's so cool. Okay, so tell us about the various media that are used in additive. Have new doors been opened since additive metal made its appearance in terms of market applications?
So a lot of people think that additive will take away, or the fear, let's say, is that additive is going to take away how everybody's been doing things for 50 years.
People are scared of change.
Yes, scared of change. It's a normal human emotion.
Yeah, exactly.
Right? Until you figure out that the change.
Yeah.
Until you figure out the change is actually a good thing, right?
That's right.
It opens new doors for you. So
that's right.
For metal additive, materials is a big one. Exotic materials that might have been too expensive to get a whole block that you're going to take away from it, or even internal cooling channels and design freedoms of how that part's going to be used. So for metal additive, let's talk about whether it be laser powder bed fusion all the way to DED. It's opened it up because it's not the same parts. It is different. They're able to leverage certain material properties that they weren't able to easily do before.
That's so awesome. All right, so lastly, let's talk about what's new on the horizon from Siemens that you can tell us about. And I'm sure we can find out more at your booth if you're here at Automate.
For sure.
But for those watching at home, tell us what we can get excited about.
There's a lot of new flexibility pieces with Siemens. Whether it be using AI to help you program controls, whether it be a more flexible programming piece as you as an engineer. We're talking about a lot of different products that we're showcasing today that actually for additive makes it easier for startups and machine builders to adapt an industrial grade, ruggedized product into their system. So that's pretty cool, and I'd love to talk to anybody that wants to talk about those things, but the one thing I'll highlight is we are showcasing a robot that is doing very high accuracy, path-dependent, high variability situations. So it might be milling, but with additive, sometimes milling and whatever your deposition extrusion head might be interacting. And have had a lot of interest over Automate about what Siemens has done with these different players. So.
It's very exciting to see and hear about. Zach, you're so passionate about this topic. You clearly love the work that you do. Why is additive manufacturing a really exciting industry to work in right now?
Because it's always new. It's not, we approached that 30 years ago and this is how we solved it. It's, no, we're trying something brand new about, melt pool monitoring that no one's ever tried to apply before. Let's really whiteboard it and think about how to approach it. I am an engineer. I was a mechanical engineer in university and everything. Yeah. And problem solving is what excites me and gets me out of bed every day, right?
Yeah,
so now with an additive manufacturing industry, you're actually problem solving. Not to say the other ones aren't problem solving.
I'm sure the problems are, solved in easier and bigger ways. It's almost like just your ability to be creative about how to solve the problem.
Yes, more flexibility. Yeah. You don't have to approach it one single way. It's, wow, there's probably 4 ways to approach this. Which one is going to be the best? Right.
That's so cool. All right. Well, Zach, it's been really fun to have you here this morning talking about the cool work that Siemens is doing in 3D printing. Like I said, if you want to check more out, Siemens has got an incredible booth here on the Automate show floor. Zach and his many colleagues will be there to give you a demo. Be sure to check out Siemens' website as well to learn more about what they can do for you and your 3D printing needs. Thank you so much for being here on this episode of Automate Live.
Thank you.